Swayam Prabha. Digital India. Educated India.
Welcome to our discussion of econometrics once again, and today what we will discuss is classical linear regression model. We are going to learn more about regression. So, this is called classical linear regression model. Classical linear regression model. So, let us first try to understand what is the meaning of classical, why this is called classical linear regression model. Do you have any idea about the meaning of classical? See, classical, like classical musics and all, classical basically indicates the foundation, right. So, that means if you know classical music, based on that you can learn many other variants of musics. Similarly, in the regression analysis, this classical regression is the basic regression model, after which econometrician they have developed different types of other econometric regression models. So, classical meanings the basic or foundation. Okay, foundation. What is the foundation of this regression model? That is classical linear regression model, or it is also known as CLRM. CLRM, right? CLRM. And what is regression? The traditional meaning of regression is basically the traditional meaning of regression is tending towards average, Francis Galton, the statistician and econometrician Francis Galton, he first used this term regression in a context what he observed that generally the taller parents, they have taller kids, taller childs, right, and shorter parents, they generally have shorter kids, shorter sons or daughter. But if you have a population of children where different child, they have parents with different height, then what we can observe, if we take any particular child's height given his parents' height, then that will tend towards the population average. Okay, that will lead to the population average. So, even though higher parents they have taller parents, they have taller kids, shorter parents they have shorter kids, on an average a kid's height tends towards the population average. That was the context in which this regression was first introduced by Francis Galton. But today when we talk about regression, it basically indicates regression analysis basically means a dependence analysis. So, what does regression means? A dependence analysis, that means dependence analysis of dependence of dependent variable on the independent variables with an objective to predict the average value of the dependent variable given a specific value of the independent one. That means when I am writing this type of model, yi equals to alpha plus beta xi plus ui in the context of consumption and income, my objective in this regression analysis is to analyze how consumption is dependent on income. That is why we say that it is the analysis of dependence on y on x with an objective to predict the average value of y. That means to predict the average value of y given xi. Okay? That is the objective. Okay? So, this is called regression analysis. This is the meaning, modern meaning of regression analysis, and the earlier meaning of regression, what was introduced by Francis Galton, is actually quite different from this analysis. Now, why we are doing this regression analysis? Because if you recall from yesterday's class, because our entire objective is to draw inference about the true population parameter alpha and beta with the help of alpha hat and beta hat. Alpha hat and beta hat is used to draw inference about the true population parameter alpha beta. And how do you estimate this alpha beta? That is by regression analysis. That is by regression analysis. So, that is why regression analysis is so important in econometrics, and there is only one technique called regression to estimate this alpha hat and beta hat with an objective to draw inference about the true population parameter alpha and beta, right. Now, the question is, okay, this is the regression analysis, but what exactly is the meaning of regression? That we need to understand, because estimating the model in today's world using the advent of softwares is very simple to estimate a model using regression analysis. But what is more important is to understand what exactly we are estimating and what is the interpretation of that. So, for that reason, I will make you understand the exact meaning of regression analysis with a simple example in the context of consumption and income. Let us say that we have a data on weekly income and consumption of some 16 families, right, 16 families, and this is the level of this is basically the level of consumption. Sorry, this is, let us start from 40, 45, 50, then 55, then 60, 65, sorry, 60, 65, 70, 75, and then 80, 85, 90, 95, and then 100, and let us say 190, 85, and once again 90, right, once again 90. This is the data on consumption. This is the data on consumption, which is denoted by Y. Now, if I ask you what is the average consumption, average weekly consumption of these families? So, that means you have 16 families data on their consumption, and you can easily calculate the mean, and that mean of consumption, mean consumption might be, let us say if you take average, that would be something around 73.7 or something, right. This is the average. How you have calculated? You have taken the sum of this and divided by 16. So, sum of summation y divided by n equals to 16, that will give you some value, right. So, that is called mean consumption of this population. Now, let us say that we know some additional information about these households, their weekly income as well, right, their weekly income. Let us assume that for this group of household, their weekly income is 60. This is, let us say, this group they have 80, and this group they have 100, and for this group it is 120. Okay. Now, I am asking you, that means I have now classified these families into 4 groups based on their weekly income. So, the first group having weekly income of 60 rupees, second group having weekly income of 80 rupees, and third group weekly income is 100 rupees, and the fourth group having weekly income 120 rupees. So, that is basically denoted by this, right. Okay. Now, I am asking you, you calculate the mean of each group. So, that means mean consumption of the group for which income is 60, and that would be something around, let us say, 47.5, and the second group, let us say, that is something around 67.5, and then this would be something 87.5, and this would be something around 91.25. Okay. Now, what is this? These means. So, that means now I am calculating mean for each group knowing their weekly income. So, that means this mean, there are several means, 47.5, 67.5, 87.5 and 92.5, they are quite different from the mean of y bar. While y bar, this is called unconditional mean, what we have calculated here, this 47.5, 67.5, 87.5 and 91.5, they are called conditional mean. That means expectation of yi given xi. So, I have derived 4 conditional means. These means are conditional upon their weekly income, right, weekly income. Now, in a simple 2-dimensional diagram, if I plot x in the y axis and xi in the y axis, and then yi in the y axis, right, yi in the y axis, and then not yi, rather I would say that this is expectation of yi given xi, right. So, what I am doing, I am just plotting this conditional mean. So, this is the first point which indicates 47.5, then second point third point and fourth point. I have simply plotted the conditional means, and if I add this, if I add this with a line, then I would get an upward sloping curve, upward sloping straight line. So, this is basically 47.5 and this is 67.5, this is 87.5 and this is 91.25. Okay. So, when we add the locus of all these conditional means, then we will get a line which is basically called the regression function or regression line. So, that means I am now getting the regression line which is called expectation of yi given xi, which is called the population regression function, the population regression function. Okay, population regression function. So, that means when I am writing yi equals to alpha, or in short this is called PRF. So, when I am writing yi equals to alpha plus beta xi plus ui, that is basically nothing but the population regression function in its stochastic form, because I have added one error term also. This is called PRF in stochastic form. And if you take expectation of yi given xi, then that would become alpha plus beta xi. Why this is so? Because we have assumed expectation of ui given xi equals to 0, mean value of ui equals to 0. Okay. So, that means the line what we got corresponding to your level of, this is 60, this is 80, this is 100, this is 120. So, that means this line what we got, when we know somebody's weekly income, we can easily calculate the conditional average of that group, and then we have 4 such groups, 4 such locus of conditional mean, and connecting all those conditional means will give you the population regression function, right. Population regression function in its, this is called deterministic. When there is no error term, this is called deterministic. PRF. And the sample counterpart of this PRF would become yi equals to actually yi hat plus ui hat. So, yi hat equals to, so yi hat is basically the, so that means this is equals to alpha hat plus beta hat xi plus ui hat. So, this is the SRF, that means the sample regression function. Once you estimate the value of the true population parameter alpha and beta, then you will get the alpha hat and beta hat, which is called sample statistic. So, this simple example basically says that what is the meaning of regression. So, regression function is nothing but different locus, a connection. A regression function is nothing but a straight line connecting the locus of several conditional mean conditional upon income. This is the meaning of regression analysis, right? This is the meaning of regression analysis. Now, how do you interpret the coefficient? See, our stochastic form population regression function says yi equals to alpha plus beta xi plus ui. Now, what is the meaning of alpha and beta? Let us say I am trying to understand the interpretation of beta. Beta from this function basically indicates for a unit change in xi, what is the change in your yi? As I said, that is nothing but marginal propensity to consume. But the problem here is, since this population regression function involves a stochastic error term, I cannot say that interpretation of beta is that, because the differentiation of yi with respect to xi will give you beta only when there is no error term involved, and then only you can interpret beta in that way, that for a unit change in income, what is the change in consumption, right. So, what we need to do then? We need to first take the expectation, and then if you take expectation of yi given xi, that becomes alpha plus beta xi, and from there if you differentiate this delta expectation of yi given xi with respect to delta xi, that now becomes your beta. And how do you interpret this? For a unit change in xi, what is the change in not actually y, rather the change in expectation of y given xi. What does it mean? So, that means, it means for a unit change in income, consumption changes by beta amount on an average. So, that on an average component is very important, because I am able to measure the change only on expectation of y given xi, not for any y. Because to get the change in y, you need to differentiate this function, which is population regression function, and that involves a stochastic error term. So, first of all, we need to take the conditional mean expectation of yi given xi, and that becomes alpha plus beta xi, and if you differentiate that, that will give you the beta value. Okay. Now, this on an average concept is even more important for some other reason. When I am saying that for a unit change in income, consumption changes by beta amount, natural question comes to our mind that for measuring a change, we need to always have a reference point. Without mentioning the reference point, the change concept is meaningless. If I say that my income changes by 10 rupees, then immediately you will ask 10 rupees from where? Is it 40 to 50 or 50 to 60 or 60 to 70 or what? What is the reference point? Unless I tell you, then the change in 10 rupees does not make sense, does not make much sense. So, whenever I am introducing a change concept in econometrics, because I am trying to interpret beta, we need to always keep in mind what is our reference point, and the reference point is basically the expectation of y given xi. So, that means the reference is from the sample average.